So, this will be our last topic under fuel. Na-skip kasi natin tong part na to. That is why, before tayo mag-proceed sa next topic, eto na talaga yung last. So, we have calorimeters. A calorimeter is defined as an apparatus or equipment used for calorimetry, the process of measuring heat transfer associated with chemical reactions, physical changes, or phase changes. In 1761, Joseph Black introduced the concept of latent heat. Latent heat is the energy released or absorbed by a body or system when it undergoes constant temperature process that leads to the creation of the first ice calorimeters. Okay, so we have what we call latent heat and sensible heat kasi. When we say latent heat, this is the heat needed para mag-change ng phase ang isang substance into another phase. Let's say, for example, this is the energy needed para mag-change ang ice into liquid water. Yan ang tinatawag natin as latent heat, or mag-change ang water into water vapor. Yan ang ibig sabihin ng latent heat. Kapag sensible heat naman, meron din tayong tinatawag na sensible heat. This is the heat that you can feel or pwede mong ma-sense, diba? Sensible. This is the type of heat na pwede mong ma-sense, or this is the amount of heat or any heat that can be measured on a thermometer. Let's say kapag mainit yung, kapag mainit yung panahon, ano yung temperature during that day? Or kapag malamig yung panahon, ano yung temperature during that day? Ganun ang sensible heat. It is the amount na pwede nating ma-feel. So, ang mini-measure natin in calorimeter is the energy released or absorbed by a body system when it undergoes constant temperature process. So, we have ice calorimeters. It measures the heat release when chemical reactions of melting ice and ice to water. So, we have two types of calorimeter. We have the bomb calorimeter and the other one, and the Boy's gas calorimeter. So let us start with the bomb calorimeter. So the bomb calorimeter, this calorimeter is used to determine the calorific value of the solid fuels and non-volatile liquid fuels. So, take note na ang mini-measure natin dito is solid and non-volatile liquid fuel. It consists of a cylindrical stainless steel vessel called a bomb, which is capable of withstanding high pressure. The bomb is provided with a lid that contains two stainless steel electrodes and an inlet valve where oxygen can be filled up to 25 atmospheric pressure. The crucible made of stainless steel or nickel or silica is then placed over a ring that is attached to one of the electrodes. A fine magnesium wire touching the weighed fuel sample is stretched across the electrodes. The electrodes are then connected to a 6-volt battery. To complete the circuit, upon switching the current, an electric spark is produced which initiates the sample to burn oxygen. So what happened in the bomb calorimeter? So we have here the bomb calorimeter. Ang nangyayari dito sa bomb calorimeter is ginagamit natin to if we have a gas as a reactant. So in this case, ang gas na reactant natin dito is the oxygen. Kasi diba, since this is still under combustion, kasi diba, may oxygen pa rin tayo na involved. So it measures, so this bomb calorimeter also, it measures the energy of the reaction. So ang nangyayari dito, sabi natin kanina, this is made up of cylindrical stainless steel. And that is, minamaintain niya yung volume natin. So, in a bomb calorimeter, you need to take note that the volume is constant. The volume is constant. So, expansion, walang expansion na nangyayari dito. Walang expansion na nangyayari sa gas natin because the volume is constant. So, this is the structure of the bomb calorimeter. So, we have here, as you can see, we have here the water jacket and the air jacket. What is the purpose of this part? So, etong air and water jacket natin dito, it It prevents heat losses. It prevents heat losses during the reaction. Ayan. So, etong nandito, dito natin ilalagay yung sample natin. Dito na part. So, we have here the temperature. So, ito ang itsura ng bomb calorimeter natin. Mas maganda sana kung meron tayong mga ganito sa lab. But, unfortunately, we don't have. Okay, so these are the variables na kailangan nating tandaan in calorimeter for our calculation later on. So, we have the mass of fuel in 2 calorimeter. So, we denote this as M in gram. Mass of water in calorimeter. The water equivalent in calorimeter. So, what is this water equivalent? Meron naman na tayong mass of water dito. So, what is this water equivalent? So, ang water equivalent natin, this is the take note na nakagram siya. So, this is the mass of water that will be absorbed or lost. This is the amount of water lost or absorbed in the reaction. We have the initial temperature of water in calorimeter, the final temperature of water in calorimeter, T2, the higher calorific value, HCV, and the heat liberated by burning of fuel. We have the M times HCV and heat gained by water, the calorimeter. So, this is the formula. Take note, sabi dito that calorimeter is a closed system. We have discussed already what is closed system, open system, during our general chemistry. So, calorimeter is a closed system. And so, with that, we have this equation. So, eto ang gagamitin natin in calculating the higher calorific value and the lower calorific value in a calorimeter. So, again, guys, this in problem solving involving calorimeter, this is just a plug and solve. Plug nyo lang yung mga values nyo dyan and i-solve nyo lang. So, ganun lang kadali as long as consistent kayo sa unit nyo and alam nyo yung mga values na pina-plug nyo. So, reading comprehension. We also have to take note some correction factors here. So, the following correction factors are considered on calculation of calorific value. So, we have the fuse wire corrections, CF. It is the correction due to the heat liberated upon ignition of the fuse wire. So, para ma-ignite yung oxygen natin, para magkaroon ng reaction. So, gumagamit tayo ng fuse wire. So, ini-ignite natin siya. So, we have the fuse wire corrections. We also have the cotton thread correction. It is the correction made by the weight of dry cotton thread used for firing. And we have the acid correction. It is the correction due to the heat formed from the oxidation of nitrogen and sulfur present in the fuel to form nitric acid and sulfuric acids, respectively. So, this correction factors, na-mention naman siya sa mga problem natin. So, huwag kayong maghanap kapag walang given. Kapag given siya, then you can use that. Pero kapag wala, edi wala. So, we also have the cooling corrections. It is the correction due to the rate and time taken for cooling of water in the calorimeter. So, we have, napansin naman natin kanina, meron tayong tinatawag na water jacket. So, yun yung correction natin. So, kapag may mga correction factor tayo, mag-change yung equation natin with this equation. Magiging gantong equation siya. Meron na tayong mga correction factors. Okay, example. So, this example can be found in your module. So, you can check your module if you want. So, we have, upon burning 0.83 gram of solid fuel in a bomb calorimeter, the temperature of 3,500 gram of water was increased from 26.5 degrees Celsius to 29.2 degrees Celsius. So, our initial temperature is this one, and our final temperature is this one, 29.2. The water equivalent of water calorimeter, so na-mention naman natin kanina yung water equivalent din, kung anong ibig sabihin nito, and the latent heat of steam are 385 and 587 cal per gram, respectively. If the fuel contains 0.7% hydrogen, calculate the HCV and and CV. So again, this is just a plug and solve problem solving. So, HCV, so this is our working equation. So as you have observed, wala naman tayo mga correction factor na na-mention dito sa problem natin. So automatically, you will use the initial equation na na-present kanina. So HCV is equal to W plus W times the change in temperature all over M. So plugging in the values, yung water equivalent natin sabi is 385. The mass of the water is 3,500, andyan. And the initial temperature, the final temperature, T2, is this one. Initial temperature is 26.5 all over. The mass of our fuel is 0.823. So our higher calorific value is 12.638 calories per gram. So take note guys that our given is our HCV must be in calories per gram. So, may mga problems, kasi baka may mga ma-encounter na naman kayong problem, just like during your exam. Kapag ang mga given is hindi let's say, baka ang given na amount of solid fuel is in moles, so i-convert nyo muna into gram, ganyan. So, take note ha, dapat consistent kayo sa mga units nyo. O baka ang given na water is in mole instead of gram. So, dapat pansinin niyo yung mga yon. Hindi porket plug and solve na sinasabi ko na dito is plug na lang kayo ng plug dun sa equation natin without considering the unit. Okay? And solving for the lower calorific value, so ang working equation natin is this one. And L stands for latent heat. So, given naman yung latent heat natin dito. So, plugging in the value, 12,638 minus 0.9 times the percent of hydrogen given is 0.07 times 587. So, the lower calorific value is 12,601 calories per gram. So, ganyan lang mag-solve ng BAM calorimeter. Next example, the following data is obtained in a BAM calorimeter. So, the weight of the crucible is 3.649. The weight of crucible plus fuel is equal to 4.687 gram. The water equivalent of calorimeter is 570 gram and the water taken in calorimeter is 2,200 gram. Observe rise in temperature is 2.3 degrees Celsius. So, ibig sabihin, ito na yung T1 minus, T2 minus T1. Cooling correction is 0.047 degrees Celsius. Acid correction is 62.6 cal. Fuse wire correction is 3.8 cal. And cotton thread correction is equal to 1.6 cal. Calculate the gross calorific value of the fuel sample if the fuel contains 6.5 hydrogen. Determine the net calorific value. Okay, so let's solve this problem. So, our working equation here, so our HCV is equal to minus the weight of water times T2 minus T1 plus, let's see, minus CA plus CF plus CC. Okay, so plugging in the value, ang ating weight of water taken in calorimeter is 2,200 gram. 2,200 gram minus the water equivalent of calorimeter is 570 gram times the change in, sabi, ang change in temperature or the observed rise in temperature is 2.3 degrees Celsius plus our cooling correction is 0.047 minus the correction factors ng CA natin, ng acid natin is 62.6 plus the fuse wire correction factor is 3.8 plus the cotton thread correction is 1.6 all over the mass of our fuel. Ang given sa atin dun kanina is the weight of the crucible and fuel plus fuel is 4.687 and the weight of the crucible is 3.649. So don't be confused kapag may mga ganitong given na dalawang mass. So, alam naman natin na ang crucible, ang given na mass ng crucible is 3.649. Eh, hindi kasali ang crucible dun sa mass of fuel natin. So, we must get the mass of fuel alone. So, isasubtract lang natin itong 4.687 minus the mass of crucible para yung fuel lang ang natitira. So, that would be 4.687 minus 3.649. This is equal to 6197 calories per gram. And the lower calorific value naman, so we have the HCV minus 0.09H times 587. So we have the calculated HCV is 6,197 minus 0.09 times the given percentage of hydrogen is 6.5 times 6.5 times 587. So this is equal to 5853.6 cal per gram. So, madali lang siya. Basta alam niyo lang kung paano kunin yung mga values, mga individual values ng mga yan. And next, we have the Boy's Gas Calorimeter. So, dito naman sa Boy's Gas Calorimeter, dun kanina is solid fuel and non-volatile liquid fuel dun sa bomb calorimeter natin. So, this time, this calorimeter is used to determine the calorific values of gaseous fuels and volatile liquid fuels. So, this is the setup of a Boy's Gas Calorimeter. Okay, so we have here the volume of gas burned at NTP in time t. We have the mass of water passed through the coil in time t, the temperature of inlet or incoming water, the temperature of the outlet, the mass condensed water in time t, the heat release of the combustion fuel, and the heat absorbed by the circulation of water. So, we have this equation. So, you need to take note of these variables. So, ang ating working equation is H is equal to W times the change in temperature over the volume. And for the lower, this is the higher calorific value, and this one is the lower calorific value. Okay, so given the following values, using the Boy's calorimeter, calculate the higher and lower calorific value per m cube at STP. Take the heat liberated in condensing water vapor and cooling the condensate as 500 kcal per kilogram. So, how will we calculate this one? First, calculating the, higher calorific value is equal to W times T2 minus T1 whole over G. That would be the weight of water is 50 kilogram times the T2 is 30 degrees Celsius minus 20 all over the volume is 0.01. 0.1 pala, 0.1 m3. So, this will be 5,000 kcal per m3. And for our lower calorific value, we have HCV minus M over V times 580. So our calculated HCV is 5,000 minus our M, weight of steam condensed is 0.15. The volume is 0.1 times 580. So this will be 4,130 kcal per m3. So that's it. So for your activity, we have here 2 items. Paki-solve siya to be submitted tomorrow. Tomorrow, 8 o'clock tomorrow. 8 o'clock a.m. tomorrow. Paki-send sa email address ko.